Hello students, this is Miss Troncone and I'm going to be giving you a short lesson on magnetism, going a little further than what you've done with Mr. Tish previously. I know you guys learned about the basic definition of magnets and magnetism and how it has a force that we can't see but is all around us, and you got to test out some objects to find out whether or not they were attracted to magnets. And I think you tested out a button and a penny and things like that, and you got to explore a little bit. And I hope when you did it, you felt that push or that pull when an object was magnetic and connected to it, because that's going to play into what we're doing today. So I want you to think about what would happen if you tried to have a magnet work through a piece of paper or a piece of wood or something like that. It would probably work, right? We could actually, real quick right now, if I take one of these paper clips and I take my magnet, and if I hold this paper clip on one side and I put the magnet on the other, it's holding it just like that. But if we got something bigger and thicker, there's a chance that it probably wouldn't work. But if you had a really big magnet, it could work. So we're going to talk about some different liquids. And there's an important word we need to know while we're doing this experiment. And that word is viscosity. So for anybody who doesn't know what viscosity is, it is how thick or thin a liquid is. And we have 3 different liquids here. And there's also going to be a short video posted for you that you can watch that'll give you another little demonstration of what viscosity is. And you do not have to watch the whole thing. I will put that in the instructions. You just have to watch for about a minute 55, and that's about it. So something right here, we have water in this glass. This is something that we would say it is not very viscous. It's very thin. It moves around very easily. And then if we skip over this one, we're going to go all the way over to this one. This is corn syrup. And when I shake it, it's not moving at all like the water is because it's very viscous. So what I want you guys to do is take a second and pause the video if you have to. I want you to make a prediction about what is going to happen when we are going to take 3 paper clips, one at a time for each glass, and we're going to drop those paper clips in. And once they reach the bottom, we're going to take a magnet and we're going to hold it up to one of the sides of the cup, and we're going to see. You need to decide, do you think the magnet is going to be strong enough to pull the paper clips to the side? Or will it work for some of them? Will it work for one of them? Because you have to keep in mind, all of these liquids have a different viscosity to them. So take a second and make your prediction. Pause me if you need to. And then we're going to go ahead and get started. So now I want you to also take a second and do just like I did in your science notebook. It could be on the same page if you have room, or if not, just flip over. And I just split my page up into 3 different spaces. And there's one for water, one for vegetable oil, and one for corn syrup. This is what you're going to use to write down your observations. They don't have to be perfect sentences. It's whatever is going to help you later when you refer back to this. What did you see? How fast did something move, or how slow did it move while it happened? Just try to be very specific in your observations, because that's what you have to do as a good scientist. Because you have to be able to refer back. So if you wanted to try this experiment again, you could look and see what you did right, what you did wrong, and what you might change about it. Okay? So again, take a second and make your little chart, and then we're going to start. So we're going to start with the water, and you can see, as I showed you before, these are sticking right to it. So let's see what happens when we try it through the water. I'm going to just drop them in. They easily go to the bottom of the cup because the water is less viscous. There's nothing it has to really force its way through. It's going right to the bottom. All right, so they're at the bottom. I'm going to take my magnet. I'm going to hold it over to the side. And I could even, they're going to follow it wherever I take it, right through that water. So take a second, write down what you observed. Maybe talk about the speed of how quickly those paper clips made it over to the side. And then we're gonna just get that one out of the way. We're gonna move to the next one. And this is vegetable oil. I'm sure you've seen your mom, your dad use it when they're cooking. It's just it's a thicker oil. So it's not as thin as this water, and it's definitely not as thick as this corn syrup, but it's somewhere in between it. It is gonna affect these paper clips and how quickly they move. So again, think about what you think is going to happen, and we're going to go ahead and drop them in. You see there's some little bubbles coming up in that one. All right, here we go. So 2 came right over. The third one's connected to the other 2 paper clips, which are connected to my magnet, which is something you can test at home too. Sometimes you take a magnet and you connect all the paper clips to it. You can see how many you can connect down, how far away they go from the magnet, but the magnet still is pulling it even though it's not touching it. And let's see if we can go around again and see if they'll follow them around. Yeah. All right, write down your observations on that. And I can show you again real quick. Just see how, I don't know if you can see, the vegetable oil is leaving a little bit of a residue. It's not all falling right back down as if you swirl the water glass. Everything just goes right back down. This is a little thicker and it's sticking. So now we're gonna go to the corn syrup. And this one will be the most fun because you saw it's barely going anywhere when I spin it around. So let's drop these in. Look at that. They're just sitting right on the top there. That's how viscous the corn syrup is. It's so thick. And just to save some time, I brought a spoon over because we could sit here all day. It would take a long time for these to reach the bottom. So I'm just going to help it along, and look at that, me pushing it down. They just need a little bit of help to make their way down. Look at, see how it's sticking to my spoon? All right. Just put that there. Let's see what happens. Are they going to come over? I'll do it on the same side as I did the other one. We want to be consistent with our experiment. I see something moving, but let's make sure you are observing how much longer it's taking. Oh, there they go. They finally made it over, but it wasn't that quick connection like the other ones, right? The other 2 liquids, even though the vegetable oil was a little thicker, this magnet was able to still pull those paper clips over very, very quickly. This took a little longer, but the magnetic pull was strong enough to still work through the viscosity of the corn syrup. And look, they're following me around, but they're taking their time. All right. So now that you've gotten to see that, you will also see on your Google Classroom that there's going to be a little worksheet for you to fill out. It's not an absolute right or wrong answer kind of worksheet. I want you all to just think about what you watched in that video, what you learned previously with Mr. Tish about magnetism, about what kind of metals are attracted and what aren't, just those certain properties you learned about. And then think about what we talked about today about viscosity, the differences. Think about what something you might like to test out on your own, and just fill it out. Tell me what you know, what you found exciting and what you learned. And that's how I'm going to look at it. I want to see that you guys are grasping the concepts that you've been taught so far about magnetism. So thank you all for tuning in and paying attention. I'm sorry we couldn't do this in person. I really wish you all got to do this with your own 2 hands, but eventually we'll get to do that stuff again. So I appreciate everybody paying attention, and I cannot wait to see your charts when you come into class next, and I'll be looking at those worksheets to see what your responses were. Thank you, everybody. See you soon.